The SMO problem year 2012 junior. Now this result that what we're trying to do today is related to something called Vieta, the Vieta formulas, where the actual roots are expressible as coefficients of the polynomial. Now you don't even have to know the name of the word Vieta. You could just do this with natural ability without even thinking about Vieta. But we're given that alpha and beta are the roots. Now any root, any zero, corresponds to a factor, which is what I've done right here. So all of this is just expansion. When you expand this out, you see that the minus the sum of the zeros, or the roots, is the coefficient of x, and the product of the roots is the constant term. And again, you don't have to know it's called Vieta. You can just simply do this. Now, when you equate coefficients, you get this statement right here: b minus 1 is the constant term, right? And alpha beta is the constant term. So we're literally equating coefficients here and here. Notice I put the minus sign here. It's a little more convenient to do it that way. Now the rest of this is just expansion and substitution, and you can verify that. Like right here, we had minus 2 alpha beta, but alpha beta is b minus 1, right? So minus 2 times b minus 1 is, where do we write that? 2 minus 2b, okay? So again, all that happened here was just a substitution from here to here, from here to here, substitution from equating the coefficients. And it's similarly down here. Now you may ask, why did I do this? Well, it's just a little bit easier to rewrite this like this, since alpha plus beta is given. Okay, so I rewrote what we're looking for. We're trying to minimize this expression, but it's easier to express it in terms of the binomial alpha plus beta squared, since alpha plus beta is actually given to us. Okay, and so the rest of it's pretty straightforward. Let's see, anything to talk about right here? We use the truth right here that if you just, in general, that if you have a plus b quantity squared, this is equal to a squared plus 2ab, a squared plus 2ab plus b squared. I'm just using b rather than having to write betas and alphas. Okay, so plus b squared, like that. And so you can see that it's convenient here to just subtract off the minus 2 alpha beta, which comes from this piece of this algebraic identity. Okay, so that's how this happened. Okay, now the rest of it is just doing substitution to get everything in terms of b, which is believable because alpha times beta is in terms of b, and alpha plus beta is in terms of b, right? So from here to here, going from this line to this line, we just did substitutions to get everything in terms of b. And so you see the 4 factors out nicely. We can complete the square. Remember, take half of the coefficient, which is minus 1/2. When you square that, you get 1/4, and you have to subtract the 1/4 from the 1, which is where this 3/4 came from. Okay, so it's real clear that this is minimized when b is equal to 1/2. When b is equal to 1/2, the right-hand side is as small as it can be. B is equal to 1/2 makes the squared term vanish. Okay, b equals 1/2, put it there, you get 0, and you would get 4 times 3/4, which is 3. So this would imply that, oh no, now I have to actually write alpha. It's not so bad, I guess. Okay, alpha minus beta quantity squared is equal to 3/4. Excuse me, 4 times 3/4, 4. This is 0, 4 times 3/4, so it's equal to 3, right, folks? Which is our answer. That's the smallest that the quantity alpha minus beta squared can be, is 3. And again, that's what we were looking for. Find the minimum value. Find the minimum value of alpha minus beta squared. And that minimum value is 3. Thanks for viewing.